on Saturday. My graduate class is on Saturday.
Yeah. So, Paul, so where did you get your PhD? So I remember you're from Ghana and you got PhD in the United States. Where did you get your PhD?
At North Carolina A&T State University.
Oh, the same university you are
The
teaching
same
right
university
now.
I'm
Oh,
teaching,
great,
yeah.
great, wow. How do you know Dr. Yao?
Yeah, so I was at JPL over 2 semesters for fellowship. And then I met Dr. What's his name? Dr. I've forgotten his name. He's into the robotics areas, controls and robotics. So we got into talking. He's also from Ghana, you know.
Mm-hmm.
So we got into talking, and then he mentioned that, oh, he has this NGO in Ghana, and the NGO, they help the high school students, you know, come up to speed on robotics, and he has this friend of his who is in charge. So I contacted him, and then Yirinchi, and we created the club at my alma mater. So that was how I got to know him.
Oh,
Yeah.
wow, yeah. You know, Graph, the organization Graph in Ghana has been working with us for more than 5 years.
Wow. I see.
Yeah, and
I see.
they're, one of the teams from Ghana last year won the, first place in game.
Oh, okay.
Yeah, they were doing great.
I see.
Yeah. I miss them. They were came to Lawrence campus every year, but this year,
Yeah, because of the COVID. Yeah.
yeah, yeah. But
Mm.
hopefully next year we'll meet again.
Yeah,
With
definitely. Definitely. So
actually,
if we want to join this team, how do we go about it?
oh, we are always welcome. So we are open always. So just
Okay,
contact us, then they
good.
can, they can, compete.
Okay, good.
So you are interested in the senior exhibition teams next
No,
year?
for the high school, remember I mentioned that the grant that we have, we are trying to groom high school students to be interested in STEM. And one way
Sure.
to do that is to introduce robotics to them.
Yeah. So
Yeah.
students from Ghana, must go through Graph. That's something, we already, set up.
Okay.
But students from your university, your project students can, come to here. So Shannon will help you, how
Okay.
to enter them, for Robofest next year. We
Sounds good.
plan World Championship actually in August next year
Wow. And
on
that will be
on
in the United
campus.
States. It will be
Yeah,
here in the United States.
yeah, on campus. That's
Oh,
our
okay.
plan. Yeah,
Okay. Hmm.
because first World Championship will be held in August next year in Detroit.
Okay.
We plan to have those, quite, similar schedule as them so that they can attend here too.
Mm-hmm. Mm-hmm. Yeah, that's a good idea. You
Yeah.
see, you are doing a great job, man. Thank you so
Oh,
much.
I mean, we have so many wonderful staff here, Shannon, Pam, Elmo, and so many judges helping. Actually, Morgan was a Robofest, students. Morgan, can you tell us about your story? How many years have you participated in, Robofest?
Good
Many
morning.
years.
So yeah, I participated in Robofest since 6th grade.
Wow.
Oh, I didn't know that.
Yeah, so I graduated high school in 2011, so that would have been 2005 or 2006, depending upon how the year laid out. And I've been a judge every year since I graduated high school,
Yeah.
except for my junior and senior year of my undergrad. I was just too busy, unfortunately.
Mm-hmm.
So it's been wonderful. And I learned a lot, and it kind of helped me get where I am now. So I like to keep participating in it.
That's good.
So, Doctor, Akanga ask questions to Morgan. He knows everything about Robofest.
Definitely, I will do that. Yeah.
Oh, hey, Andrea, nice to see you.
Hi, CJ. How's it going?
Good, good. Yeah. Andrea has been participating in Robofest so many years. Also,
Okay.
she was an intern at Robofest office
Oh, okay.
before before she goes to MIT. So, wow, nice to see you.
Hi. Lots of new faces around here. Good to see everybody.
Yeah.
Oh, Andrea, Josh, Professor Seeger is here. He was also in the Department of Mechanical Engineering at MIT. So I think
I don't know if we overlapped. I was there.
graduates earlier.
I was there 2008 through 2016.
Okay, interesting. I was there 2014 to 2018.
Okay.
So maybe just a little, but you were doing an advanced degree at the
I would have
time.
been, wrapping up my PhD and then doing.
Gotcha.
So.
What professor did you work with?
I worked with Sanjay Sarma.
Oh, people say good things.
He's a good
Awesome.
guy.
Yeah.
Yeah. Which group were you working with?
I was an undergrad, but I did some work with like controls and instrumentation.
Awesome.
I worked in Amos's lab a little bit.
Oh, you were working with Amos Winter?
Yep.
Okay. Yeah.
Not extensively, but as an undergrad.
I'm cognizant that we are live on Facebook now, so we can follow up offline, but I think that we do know a bunch of people in common then.
Yeah, for sure.
That's great.
We are live on Facebook.
Yep, time, I think, to start.
Yeah.
Okay.
Okay, Shian, did you get there's a message about Zoya's devices? Are we, is that back?
Bring her on. Okay, Zoya, let me see. Yep, we're just gonna do a little bit of housekeeping real quick. I don't see,
Yeah, I don't see on the.
I don't see her on the attendees list. We can definitely bring her in when she's logged back in. Is anyone else on the attendees list that wants to be brought in from the Phoenix Cubitex team for the group photo? We have one team that's spread around several locations, but only 2 of them are going to be participating, but we want the other 3 students on the team to be part of the group photo. So if you're a part of the Phoenix Cubitex and you want to be in the group photo, raise your hand. We're going to get started in just a moment. We are live on Facebook.
Yeah, go back in the chat if you're back in, but yeah, we don't see you yet.
We don't see Zoya's device yet logged in, unless it's under a different name.
Okay, so Vita, it says. Okay, I see. I think we found them.
Okay,
Okay.
all right.
Okay, I think we're almost
Yeah, if
ready.
everyone could turn on their video. We're going to have a very, very crowded gallery, which is wonderful.
Yeah, multi-page gallery.
Yeah, it's great. We have to remember that for the photo to make sure to
Yep.
get everybody.
Okay.
3074, Mark Townsend cannot raise his hand.
Okay, I don't think that's a necessary at this point.
Right.
Yeah, I was looking for any attendees on the side, on the attendee side. If you're already a panelist, if you already have a screen, yeah, we don't need you to raise hand on that side, just if you wanted to be brought over as a panelist for the photo. So the team from Saudi Arabia, the team, Gavin, are you there? Okay, for the second cameras for each group, I'm gonna, anything that's a secondary camera, I'm gonna send to the attendee. Is Sarang there? Is Gavin?
Yeah, I'm there.
Okay, can you turn on your video? Okay, I'm gonna take your other one. Angelica, I see myself. I want to see the team. There we go. Anyone else? The Saudi team, yes, the Saudi team did come in. Awesome, okay.
I can't start my video because the host stopped it.
Oh, which,
Here, I'll
yeah, sorry about that.
Okay, here I am.
There we go.
Okay, I'll try not to do that again, but we were trying to make sure everything looked really clean for the presentation and the photo. Okay, if you don't have your video on the gallery, it means you don't have your video on. So if you want to be in the gallery for the photo, turn on your video. I don't know if you can see what I'm seeing. I see Gavin Coleman's not in yet.
okay. I think we need to start though. It's
Okay.
getting,
Okay, very good. So welcome everybody. My name is Pam Sparks and I will be your MC for today. We are so excited to be here with so many talented students and coaches and judges. And of course, our Robofest staff. We have acting as chief judge today, we have Elmer Santos. And coordinating the magic behind the scenes, we have Shannon Polonis. And we have our own Dr. Jung here today, who will be saying a couple words at the end of our presentation. We are so glad to see everybody. It's taken a lot of work to get here. Check-in was fantastic. Everyone got on early. Thank you so much. We are ready to go. Nice job, coaches. The magic just doesn't happen, but you made it happen. Very good. We would also like to welcome spectators. So if you have any friends or family that you want to text real quick, there's a link that we just reposted in chat and on Facebook where you can actually join the Zoom webinar. The advantage of being on Zoom webinar is that you can participate with the Q&A function, and those questions will be sent out to the teams, and the quality is better. There's not so much of a lag as sometimes we experience on Facebook. So we would encourage you, if you are on Facebook Live, just click on that link that you see and switch over to webinar so you can more actively participate. Okay, so for those of you who are in the webinar, if you have questions for the team, that's presenting, please include the team ID and the team name. So let me say that again. If you are in the webinar as a spectator or attendee, you can put a question in the Q&A and please include the team ID and the team name. Where will you find those? The team ID can be found on the team profile picture or on the team sign. And as I said at the end, questions and answers will be summarized and submitted to the teams by email. Any communication, if there is any outstanding communication, our chief judge, Elmer Santos, will make sure that that is communicated to you. So thank you for that, Mr. Santos. We are a program of Lawrence Technological University in Southfield, Michigan, USA. And these are our amazing sponsors. So these great companies are giving back to the community through Robofest, and we can't thank them enough for participating with us. As most of you probably know, exhibition is the fourth in a series of competitions. So we are excited. This is our exhibition weekend. Today is the junior exhibition, and tomorrow we will have the senior exhibition categories. If you find the blue box here on the screen, this is our program for today. Our opening here will take about 15 minutes. And we are next going to have a welcome from Lawrence Technological University.
Greetings, friends of Lawrence Technological University all over the world. We welcome you to the first ever Robofest 2020 Online World Championship, the only robotic competition in the world this year. I am Virendra Modgil, President and CEO of Lawrence Technological University in Michigan, USA. As you know, Robofest is all about STEM, science, technology, engineering, and mathematics learning. Success at Robofest requires mastery of multiple STEM and computer science subjects, which in turn drives preparation for college classes and high-tech careers. Additionally, Robofest teaches students to develop soft skills such as problem solving, teamwork, creativity, and communication. This year marks our 21st Robofest season. 2020 will be unforgettable. Due to the coronavirus situation, all the qualifying and regional competition around the world were abruptly halted in early March. However, we did not want to halt the learning opportunity for students. LTU's Robofest created new modality in the competition-based learning environment to cope with the unpredictable future rather than canceling it. So thank you for your participation in this new, unique, and different format of competition. I commend all of the teams and students here for being active learners and pioneers who are eager to master technologies for the future. As you may know, Lawrence Technological University was founded in 1932 with the support of the auto pioneer Henry Ford. At that time, Ford's famous Model T factory was at the forefront of an industrial revolution that changed the world. Likewise, we are at such a forefront of new technologies today. LTU and Robofest are paving the way. Someday, I hope you will join us here at Lawrence Tech to continue to do the excellent work you are already doing with LTU's Robofest. Your efforts are advancing science and technology for solving real-world problems. At this time, I would like to thank all the teachers, coaches, mentors, and parents. You make this program possible for our students. Without you, teams do not exist. Additionally, I would like to thank all of the inspirational international directors who have organized local qualifying competitions or are sending teams to Robofest 2020 Online Championship. Finally, we cannot give enough thanks to Robofest's local judges and LTU judges for their dedication and volunteerism. Let us give all of them a round of applause. In closing, I wish all of you luck with your endeavors today and hope you have a great connected learning and collaboration experience through this unprecedented online Robofest 2020 competition.
Okay, thank you, Dr. Mogul, for your vision. At this time, we would like to show you the screen of the order of teams. So teams, if you would take a moment and find your team. And this was shared at the coaches meeting yesterday, but so that you know the order that you are going to be going in. So how are you going to be judged today? And how do we decide the winners for exhibition style team? We'd like to thank the teams for already submitting their video link and their source code. We have our judges here today, the judges will introduce themselves in just a minute. So what's going to happen after our group picture is the host is going to bring each team on one at a time to the virtual stage. Your team will have 4 minutes to present and demo your robots. The judges will ask live questions for 2 minutes after the presentation. It is required that teams use English for all communications. Judges' questions may be translated at the local level only when teams do not understand. However, teams must answer directly in English. Judges may send chat text as well for questions, and our Chief Judge Elmer will be monitoring that today. Judges may ask additional questions by email within 24 hours after the competition. And we've already gone over the modified online rubric, so we should be all set on that. Okay, so at this time, we would like to ask each of the judges to introduce themselves. So we're going to start with our very own Mr. Elmer Santos, our Chief Judge today. Could you introduce yourself, please?
Yeah. Hello, everyone. My name is Elmer Santos. I am the Robofest Assistant Director, and I'm also the Chairperson and Chief Judge for the Junior Exhibition Competition. I am a mechanical engineer by training. In my previous career, I worked at General Motors for over 30 years in various functions in manufacturing engineering. In the past, I've also worked with a number of robotics competitions like First Robotics, Vex Robotics, World Robot Olympiad, and of course, Robofest, which is my favorite. So thank you all for coming.
Okay, wonderful. Thank you, Mr. Santos. Next, if we could bring Dr. Paul Akanga to the stage.
Hey, everybody. It's nice to be here. Again, my name is Paul Akanga. I'm an assistant professor of mechanical engineering at the North Carolina A&T State University. And my area of expertise is advanced composite materials. And it's a pleasure to be here. Thank you so much.
we love your enthusiasm. Thank you. Mr. David Carberry, if you could introduce yourself, please.
Good morning. My name is David Carberry. I graduated from Lawrence Tech in 1989 with a Bachelor of Science in Electrical Engineering. I've been working at Fanuc Robotics for over 30 years and am in the product development group over there. I've coached and judged for several years with Robofest, and I'm currently working as a judge for you guys today. Good luck, teams.
Okay, thank you, Mr. Carberry, for all of your years of volunteering with Robofest. We appreciate you. Mr. Morgan McCain, could you introduce yourself?
Yeah, thank you. Good morning. My name is Morgan McCann, and I am a graduate of Lawrence Technological University. I graduated with a bachelor's in mechanical engineering in 2018, and I am working on a master's in mechatronic systems engineering currently. I am currently employed at General Motors, and I've been participating in Robofest since 6th grade, which was about 2006 timeframe. And every year since that, I've either been a participant or a judge. Thank you guys very much.
Okay, fantastic. Lots of experience here today as judges and as students. Miss Andrea Meister, if you could introduce yourself, please.
Hi folks, I'm Andrea Meister. I've been with Robofest in some capacity since 2007. I currently work in supply chain robotics at Vecna Robotics. Good luck, everybody.
Okay, fantastic. Another judge with lots of experience. We're going to get some good scores today. Mr. Waming Jing, could you introduce yourself?
Yes. Hello, everybody. I'm really glad to be here. I did some research on robotics back in Stevens Institute of Technology in New Jersey, USA. And I'm currently working as a faculty here at LTU. my interests are in very small robotics, right? But really glad to be here to see all the young children doing their interesting topics, right? Good luck.
Well, thank you for joining us with all your talents. And our final judge today is Dr. Josh Siegel.
Hi, everyone. I'm Josh Siegel. I'm an assistant professor of computer science and engineering at Michigan State University. Before getting involved with CS, where I now work with the Internet of Things and self-driving cars, I got a PhD in mechanical engineering. And I've been involved with Robofest in some form or another since 2001, when I started as a competitor. So I missed the first year of it. I think I'm first or second year, maybe. But 19 years of doing this and love it every year. So very happy to be a part of it. Thank you for having me.
Oh, thank you for being here. Yes, Dr. Chung started the program in 1999. So you were pretty close to the beginning.
Close to the start.
Yeah, that's pretty impressive. So thank you for being here. Okay, so at this time, let's bring everybody for the group photo. So what we want you to do is to look at your thumbnail, everyone, teams, judges, and support staff, and make sure your video is on, and look and make sure that you look like you want to look in the photo. Okay, so we're going to take several photos. So we're going to have a little bit of a photo shoot here. So here we go. We've got, there's screen one, and there we go. Here's screen two. And I think we all got on 2 screens. Okay, very good job, everybody. At this time, Shannon's gonna work some of her magic, and we're gonna bring the first team on stage and put all the teams that are waiting. We're gonna put you into the auditorium, out as a spectator.
Okay, so Bryce, are you ready? Bryce is going to be our first team, 1990-1. So everybody else, I'm going to put you over into the attendees list. So we'll bring you back in. I'm going to start at the bottom if somebody else wants to start at the top. Just give us another moment here. Okay, we should be good. Bryce, you can unmute yourself.
Okay, so judges, are we ready? Give me a thumbs up, judges. Woohoo! Okay, Bryce, are you ready?
Yep.
Okay, you may begin at any time.
Hello, this is Bryce Sting from Team Technomass's ID 1990. I'm currently in 6th grade and I'm in Hillside Middle School. This is my project that has something to do with global warming. Global warming is one of the most commonly known and most serious problems in the world. The average amount of CO2 being released into the air each year is approximately 37 billion tons. So I decided to try to cut down that amount by making a robot that goes up to factories, sucks in CO2, and puts it onto a green room. So our robot over here, which we nicknamed the semi-truck, consists of an EV3, which powers these 2 motors and these 2 light sensors. By using the PED controller system, to follow this giant blue line. And then there's also 3 other Arduino Unos on here. One's right here, which powers this valve right here. And then another one's inside the tank to monitor the pressure of the tanks, which can kind of tell us how much CO2 is inside. And then it sends it using an XP over to this other Arduino Uno, which also has an XP to receive it, and then it displays how much pressure and temperature is inside. And also it's connected to a virtual wire transmitter, which is going to be pretty useful later on. So over here, you can see this is our factory. It has this red line right here, which the robot's going to stop at. Then the virtual wire transmitter on here will send a signal to this EV shield, which is connected to an Arduino Uno, and then it has another virtual wire receiver on it. That receives it, and once it does, it lowers the pipe into the valve, into this funnel, and then the valve opens, and this pipe runs, sucking CO2 and putting it into the tank. Then after it's done, the pump closes, the pipe goes back up, and then this valve closes. Let's see this in action. So our robot has already gotten a pit stop at the factory, and then you see this yellow line right here. It's going to do the exact same as it's going to do with the factory, except there's no food, and the CO2 is going from the tank inside into the greenhouse. And then you see inside the greenhouse, there's approximately 6 different sensors. And if you can see on here, on the processing, you can see each sensor's readings of how much luminescence, humidity, temperature, moisture, and CO2 and ppm. Now, you might be wondering about this. Well, if I press 3 on this remote control, the lights turn on. And also, this keeps track of when they're on and off. With 2, the fans turn. And of course, it keeps track of when they're on or off. That was the factory back there. And now with 1, the pumps turn on, which is the irrigation system. And then each valve will take turns opening and dripping water, watering the plants underneath. And of course, this keeps track of when they're on and off. This is Bryce Ting from Team Techno Mouses signing out. I'm done. So, any questions?
Okay, so that was a fantastic job. Judges, do you have any questions?
Yeah, I'm sorry I was on mute.
Oh, that's okay. We're good.
Yeah, but yeah, judges, any questions?
Yes, I do have.
Okay, go ahead. Go ahead.
Young man, I think you made a very wonderful presentation. My question to you, I think I have 2 questions. The first one is, how do you hope to capture the CO2 at the factory level? How do you plan on doing that? And then the second.
Why don't you repeat that again?
Okay, how do you hope to capture the CO2 at the factory level?
Well, we're mainly trying to suck the CO2 from the factory. If you remember, there's a vacuum pump over there. Basically, all that CO2 in the air is supposed to be sucked in and then put into the tank, which we're going to release into the greenhouse. What we're trying to do is putting it into a greenhouse is that hopefully the plants can turn it into oxygen or just completely get rid of it completely.
Mm-hmm.
So then we can release it into the air.
Okay, thank you. And then my second question is, how did you originate this idea?
Okay, so to be honest, when I started this, I had no idea what to do. I always thought of like something really cool that had nothing to do with climbing. Once I heard the theme, I was pretty stuck. What can I do what can I do for the exhibition that has something to do with the theme that's pretty interesting? So I decided to start with a problem. What kind of problems in the climate are there? Which brought me to global warming. So after I thought of global warming, I decided to think of some ways to try to cut down how much greenhouse gases there are in the air. So I decided to go to carbon dioxide because it's much more abundant. It's probably one of the most common and abundant greenhouse gases there are, and also it's pretty effective too. So then I decided to do something with CO2. And then when I remembered that plants can suck CO2 and turn into oxygen or something, I decided to try to get CO2 into a greenhouse somehow.
Okay,
Thank you so much.
Yeah, we're unfortunately we're out of time for the questions and answers, but yeah, judges, if there's something left to ask, just take note and we'll email them afterwards. Okay, so thank you very much, Techno Mouse. Next team up is Pineapple Adventure.
Do we start?
And just give us a minute here. Okay, do we have all our judges back?
Yeah.
Okay, yeah, sorry about that, Morgan.
Oh, it's their turn.
Yep. Okay, go ahead. You can start when you're ready.
Okay. We're team 2720-5, Pineapple Adventure. I'm on the team with my sister Kaylin, my brother Colin. I did the programming and I modified the robot. Colin built some of it and Kaylin's presenting.
When the coronavirus pandemic hit Michigan, people rushed to the store before lockdown. Most people didn't want to leave their homes since there wasn't a vaccine for COVID-19. So they stocked up on supplies, especially toilet paper. This started a toilet paper shortage. Once we ran out of toilet paper, we had to buy camping toilet paper, which was half the normal size. And at first, this was fine because it could fit on the toilet paper holder. But after a month, we ran out and we had to buy the big industrial size toilet paper rolls, which did not, unfortunately, fit on the toilet paper holder. So we had to save the cardboard remainings of other toilet paper rolls and roll it up from the industrial size. This was something that no one in our house wanted to do, so we decided to have a robot do it for us.
We didn't want to make this a big project at first, just a way to eliminate the person holding the cardboard rolling the toilet paper. We used the motor duct taped to a table. The motor held the toilet paper and spun forward while someone held the large roll. This still took forever, so I decided to have the robot do it all for us. We built a stand for the big toilet paper roll to sit on. However, the stand was not perfect. Someone still had to make sure the toilet paper stayed in one spot. Also, the toilet paper would fold in half before reaching the roll. Plus, we still had to manually stop the robot once the toilet paper roll was large enough. To stop the toilet paper from folding, we taped a wheel held up by Legos that the toilet paper would go under, making the roll tighter and preventing folds. Next, we put tires on the bar, folding up the large toilet paper, preventing it from moving. Now the end result was closer. Together, lastly, we put a sensor where we wanted the top of the toilet paper to be. Once the sensor received a value, it shut off.
So we don't have very much time left. So this one right here is one that the robot rolled, and this is one that was rolled in the factory.
All right, are you finished?
Yeah.
All right, thank you very much. All right, are there questions?
Yeah,
David has his hand up.
Yeah, go ahead.
Could you explain how it stops automatically when the roll is full?
We have a sensor right here. It senses when it's high enough. Right here. Can you see it?
Yep.
Okay.
Okay. Another question. Go ahead, Andrea.
Hi guys, what kind of tests and iterations did you make on your design?
So we started, like, we didn't have this, so it kept folding. We put this here so it stopped and we like made it tighter. And then we also put tires right here to hold the toilet paper in place.
Turn your thing off.
Is there a way to detect if the paper breaks?
It's never broken before.
Okay, good. Well, that's a good solution.
Okay, Dr. Siegel has a question.
Yeah, I was going to ask also about detecting breakage, but given that I can't ask that now, did you test the feeder at different speeds?
No,
Set a gearing and see if it worked.
we didn't test it at different speeds.
Okay.
Hey guys, did you test different like types of toilet paper, like 2-ply or single ply, to see if maybe the torque of the motor might rip cheaper toilet paper versus the more expensive toilet paper?
This is the only one that was available that we could use because everything else we couldn't buy.
Fair enough. There's a shortage.
It's testing. Okay, I think it looks like we're just about out of time for questions, but thank you very much. Well done.
Thanks.
Thank you.
Okay, time for the next team. 2782-2 Robo Corin team. All right, do we have them on? Okay, yeah, go ahead. You may begin when you're ready.
So this is Tiny Tin, and I'm Austin. I'm Leo. Background information. Created because scientists predicted a global flooding due to climate changes and global warnings. Mobile city construct. Incredible large and can move on land and on sea. Can move from place to place and avoiding natural disasters and other events. Can be piloted manually or auto using sensors to avoid objects. The drawback negation field generator is an artificial gravity creator that is a specialized electromagnetic field that interacts with the iron in a human's blood, putting out the ideal push and pull across the city to keep people on it. It generates its own electricity by wind, solar, hydroelectric, and hydrogen power. Tiny Tin has deployable cups for moving through the water easier, and pontoons under the city keep it afloat on water. It's made of a strong and lightweight metal alloy named gigrimium that does not rust because it contains no iron. It travels at 200 miles per hour in water and 150 miles per hour on land due to highly advanced engines. Static electricity allows it to go over waves in the water by pushing the waves under the ship.
city services. It requires about 1,000 people. The teleportation system throughout the city allows the fast transportation and amenities. Filters collect ocean waters and fluid. It goes throughout the city and rainwater is collected as well. Farm location on the city and uses no chemicals. Trash is taken care of, canned throughout the particles spreads. Each molecule is made into something else. City services train that system that services around the city. Chemicals is shopping areas for residents. Factors in instructed areas. Government zones, city mayors, councilors, and pilots of the city. Defenses system, gun turrets, and the city and military forces as well as police presidents.
Trade and commerce. Use of boats and planes. The receiving city must make an intercept course and remain still. It has satellites. Farms and fishing are big industries as well as land-based mining. It has specially equipped submarines that tunnel underwater to find resources. Also, it can get resources through the separation and combination of different particles to form new substances. So the program repeats an if-then-else loop to check for obstacles with the ultrasonic sensor. If it detects an obstacle, then it will back up and turn left or right until there is no obstacle.
Yeah.
We're good. That's it.
All right, thank you very much. All right, who would like to start the question? Okay, Dr. Siegel.
Yeah, I'm just curious how you decided on the ultrasonic sensor for collision avoidance and if you looked at any other options.
Can you repeat that, please?
You said that you're using an ultrasonic sensor to avoid colliding with things, right?
Yes.
How did you choose that particular type of sensor?
Well, it sends out waves. So like within a 30 centimeter perimeter, it will stop and then turn until it finds nothing. So we just thought that the ultrasonic sensors were the best thing to use.
Great, thank you.
Yes, my question also was like, how many sensors are there, right? It's
There
like
are two in the front.
Two in the front.
yeah. So do they have any on the side or on the back, or that's the only sensor you have on board?
Yes.
Yes.
Okay. Mhm.
And you can control it manually. So
yeah,
I guess this would be where the pilots are.
Right here.
In the front.
Thanks. Mhm.
How did you come up with that idea for the overall concept?
Global warming. We thought that there was the global warming problem could cause a flood. So we made this so it can travel on land and water. And this is there's supposed to be a city inside of it. So it makes its own gravity. So to keep people on the correct push and pull to keep them on the city.
All right, thank you very much. We're out of time, but thank you so much. Okay, next up we have 2900-3 Met.
Hi. Can we start?
Do we have both your cameras on yet?
They're both on.
Okay, go ahead. You can start when you're ready.
Okay. Hi, we're Team Med from the category exhibition. We are from Mexico. I'm from the school Electronic. My name is Diego.
My name is Santiago. And my name is Luis Fernando.
Well, this is our project that it's called the Digital Arithmetic Box for the blind children. Well, we have this idea because the original arithmetic box is just like a box of wood with spaces that have like a number or a symbol for doing arithmetic operations. So, well, we analyzed this and we saw that this is very stressful for the children that are blind. So we decided to put it sounds because, as you know, blind people have like a very hearing sense. So we decided to approach that and we put it with sounds.
Now how it works. First, you need to put a finger or just cover one sensor of the holes, and then it's going to send us a value. Arduino is going to process it and search the .wav files that we have in the SD card with the SD card reader, and then send the voltage to the speaker, and the speaker will say the noise that we want. Now, what about STEM?
First of all, science. We analyze and we check all the necessities of the blind people or children, and we decide to do a project that can cover it.
Technology, using our robotics knowledge and the skills to design and build the prototype. Applying all the necessities. Engineering, building with ingenuity the prototype that simplifies the use of the arithmetical box for speeds of mathematical operations.
And finally, mathematics. We use the mathematics in this program, in this problem, by tracing and calculating all the spaces that we have here, and in the program by comparing all the values that we have in the sensors. And now my teammate Santi is going to make a quick test of how the box works with this operation. That it's 2 by 3.
Dos.
As you can hear, the box says the number 2 in this case, that is dos in Spanish.
Más.
This in this case
Cero.
says más or plus. And this program works with 4 libraries. One for the communication between 2 Arduinos, one for the SD card reader, another for reproduce the sounds, and the other for the SPI communication.
We also make our own Cooper board for the circuit that has like all the wires that we want and all the resistors that we use.
Yes, because in the beginning, it was made with breadboards, and it was a mess of cables and resistance. So we decided to do the copper board. Also, another advantage that our project has that you can modify the audios to be in different languages. For example, English, I don't know, Chinese, for example.
And now, as you can see here, the operation is finished. Is 2 by 3 equals 6, and is faster than the other box. And in this video, we are showing you how the circuit is made. We have a lot of resistors and cables that are attached to the Cooper board that we have. And below that, we have 2 Arduinos, 2 Arduino Megas for all the sensors that we have and the SD card reader.
Just imagine this can be very helpful for the children.
All right, time is up.
Yes. Thank you.
All right, thank you very much. Do we have questions? Yeah, go ahead, Andrea.
I'm curious, were you able to test with any blind users? And if so, what did they think?
We tried it before this time of the issue with the pandemic, but we go to a foundation here in Mexico, and they thought that it's a very good idea and can be very useful.
Yes, but because of the pandemic, we can't test it in an actual blind person. Another question?
Yeah, is there a problem if it detects reaching into the same compartment twice?
No, because we have all the compartments like separate with another like spaces that we have here. Here is separate, but with this line. We use infrared sensors.
Okay, and the I'm not sure if I totally understand the concept. So is the calculator actually doing the operation as well as detecting what piece was picked out?
Oh, isn't a calculator. It's just a box that says you the number that you pick.
Okay.
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 Yes.
Okay. Thank you for that clarification.
Yeah.
Could this be expanded to more advanced mathematical operators?
The function of the arithmetic box is you need to do it, the actual operation, but we can extend it, for example, with more numbers or with more symbols. But the problem is that here in Mexico, the standard arithmetic box is just made with these symbols and numbers because are like the basic ones.
Okay, time is up. But thank you very much.
Thank you.
Thank you.
Good luck.
Yeah, thank you. Okay. Next team is 2928-5. Tanay Panja.
Hello. Hold on.
Yep, take your time. Just go ahead when you're ready.
Okay. Make sure everything is connected. Okay. Hi, my name is Tanay Panja, and I'm 12 years old, participating in junior exhibition for Robofest. I've completed high school level programming courses, and my project name is Machine Learning for Smart Delivery. I've developed a Raspberry Pi-based access control system using machine learning and image recognition for autonomous delivery robots. The problem is, how can I prevent an item from being misplaced from a delivery robot? I took a machine learning summer camp with Dr. Chung organized by Robofest. From there, I got inspired to learn more about machine learning and using image recognition. Delivery bots can deliver food to students in their dorm room, food and grocery, supply medicine and medical equipment. How does a delivery robot ensure they are delivering the right things to the right person? Access control in these delivery robots are important as people could steal or misplace an item. This is my robot. So the price is $129 US dollars. And let's show you the parts. Here we have the Raspberry Pi, which is the brain of the robot. Here we have the camera, which receives the video feed. Here we have the solenoid lock, which has two positions, the lock position and the unlock position. Here we have the relay, which allows communication between the Raspberry Pi and the solenoid lock. And here we have motors and wheels on both sides, controlled by the motor control here. So let's see a little demo of the robot. You can see here, when I put my face in front of the camera, you can see it says Tanay and the solenoid lock unlocks for me. It also works if I have my mask on. You can see it says Tanay and the solenoid lock unlocks for me. Let's say Mr. Elon Musk walked up. You can see it says unknown because he is not in my customer database, and the solenoid lock remains locked. Let's say Mr. Bill Gates walked up. You can see it says unknown because, again, he's not in my customer database, and the solenoid lock remains locked. I have two data sets with multiple photographs, one of me and one of my dad. I used a program called encodefaces.py
to store any face encodings and locations from the dataset into a .pickle file. In the main program, which includes the solenoid lock, I open the .pickle file and read and compare the face encodings. Let's see the code. Can you see my screen?
Yes.
Okay. First, we import any necessary libraries. Then we initialize the solenoid lock. Then we print any necessary information and start the video stream. We read the frame, resize it, and convert it to grayscale to detect it. And we also detect the faces. We put boxes, and we take the matches and compare the faces with the known face encodings in the pickle file. And then we get the name, which is the most occurrences of the name it sees, and then we append it to the list of people it sees.
Okay, time is up.
Oh.
All right, thank you.
Okay.
All right, Tay, could you stop the screen sharing?
Yeah. Sorry
okay.
about I couldn't get the whole code.
Oh, that's okay. I think we get the idea. Who has questions? Yeah, Dr. Siegel, go ahead.
Tanae, if Bill Gates wanted to steal a package from the delivery robot that was addressed to you and he had a printout of your face, what do you think would happen? And have you thought about how you might deal with that situation?
Well, I might have it, so maybe we can add more sensors to see if it's the actual person, not like a person just putting a paper to see paper just to get in. So maybe you could have infrared sensors to detect the body heat. We could have like PIR sensors to detect motion and stuff like that.
Awesome.
So additional sensors. And also I have an idea of using barcodes and QR codes so that it's not just limited to the camera. If users do not want to show their face or anything, they can just use QR codes or barcodes on their app or on their phone.
Great, thank you.
Okay. Any more questions?
Have you programmed any of the autonomous aspects of the vehicle itself?
Oh, so what makes it autonomous is that the access control system, what is it? The access control is autonomous by itself because it receives the video feed and it can process it autonomously without the help of a human being. But also it can drive, but right now I'm working on the autonomous portion of making it like move autonomously.
Okay, I see. That's the next part. Okay.
Yeah.
Yeah, so I do have a question. So is there a way to track your vehicle during transit to know where it is at any point in time?
So that's another future research direction. Like maybe we could associate an app to know the exact GPS location of the robot in motion. And it's very necessary. Also, for the face recognition, I got introduced with Power Cascade classifiers, which detects phase of shapes and use deep learning methods to detect your face. And I use a library called face recognition to detect and compare the faces using known face encodings.
Wonderful.
Okay, I think we're about out of time. I'm sorry I started the timer a little late, but I think yeah, that's about it for the time. Thank you very much.
Okay.
Okay, next up we have team 3074-1, Phoenix Cubitex. Okay, we have everyone in?
I believe so.
I'm here too. Yeah,
Okay, good. Go ahead when you're ready.
We are team 3074-1, the Phoenix Cubitex. I am Mark, and I retrofitted the icebreaker to fit inside already built walls.
I am Jensen, and I helped wire and code the icebreaker, our robotic solution to the problem of freezing pipes.
We are representing our other teammates, Zoya, Abdullahad, and Adil, who could not be here today.
We've shared our ideas with many experts and updated the icebreaker based on new ideas and feedback. We also conducted multiple surveys with over 100 responses to see how it could be implemented in the real world.
The icebreaker, our robotic solution to the problem of freezing pipes, has a temperature sensor to measure the temperature of the water pipe. If it detects below freezing temperatures, it will send a signal to this Arduino board. The Arduino board will supply power to this eco-friendly heating pad using a MOSFET transistor. For the demo, we are indoors and unable to replicate freezing temperatures. Therefore, we utilize the app we created for our device to adjust the device's activation temperature to be 8 degrees Celsius and use this ice pack to get the pipe to be that temperature. The pad will warm the water that would be inside the pipe to above freezing, which prevents it from expanding and causing the pipe to burst. As soon as the water is above freezing or whatever temperature the user inputted, the device detects it and turns off the heating pad to conserve electricity. The device also has an LCD display. The LCD display shows the user the current temperature of the pipe and whether or not the heating pad is currently active. As you can see, the pipe is 8 degrees Celsius and the heating pad is active. As soon as the water is above freezing or whatever temperature the user inputted, the device detects it and turns off the heating pad to conserve electricity. Additionally, the device utilizes an HC06 Bluetooth module that allows the device to interface with an app. Through the app, the user can see a graph of the changing temperature of the water pipe, the current temperature of the pipe, if the heating pad is currently active, and activate and deactivate the device. The device works with the battery or can be plugged into an electrical outlet if one is available. The code begins with importing libraries. We use functions from the liquid crystal library to help control the LCD display. We use functions from the wire library to control the HC06 sensor. Next, we created some constants to describe the pin numbers of the devices. This allows someone who doesn't know the wiring of our device to have an easier time understanding our code. When we define the pins, the heating pin controls the heating pad. Therefore, this pin is an output because we are not receiving information from it. We are using it to send information. The temperature sensor pin is an input because we are receiving information from it. After that, we read the analog value from the temperature sensor and use the mathematical relationships between the temperature sensor's analog value, voltage, and degrees Celsius to determine the pipe's temperature. We communicate this information with the app by printing it on the serial monitor. We also display this information on the LCD display by using liquid crystal commands. Next, we use conditional statements to determine whether the app has taken manual control of the device, and if so, does the user want the heating pad to be active or inactive? We update the LCD display accordingly. Finally, if manual control was not taken, conditionals are used to determine whether the heating pad should be on based on the pipe's temperature. The LCD display is also updated. If the temperature is above freezing, the heating pad deactivates to conserve electricity. After this, the device waits 5 minutes to repeat the cycle of checking the pipe's temperature and activating or deactivating the heating pad. This 5-minute wait helps to save energy.
The icebreaker can be installed on exposed pipes as well as pipes located inside walls. To show you how the icebreaker can be placed on an interior pipe, our team created this prototype. The device can be mounted behind walls by simply cutting into the drywall and installing this access panel, which can be found at any Menards or Home Depot. As you can see, just about anybody can install the icebreaker, whether the pipe is exposed or not.
Our demo might not have as many bells and whistles as other teams, but when sharing our device with a foreman plumber, a builder, and an entrepreneurship company, all of them felt it was an innovative solution that if put into production would be extremely useful. Thank you.
All right. Okay, time for Q&A. Who has questions? Hey, go ahead, Andrea.
If you were going to make your robot into a real product, what are the first things that you would change or improve?
One of the first things we worked on improving is, well, we make it so it doesn't have this huge mess of wires on it. So we'd probably use a personal circuit board, PCB technology, that would not only reduce the cost of the device, but it would also make it smaller so it doesn't need to take up this large an area and make it more user-friendly. We've also actually contacted the Startup Council on trying to patent our device.
That's good. Yeah, so I do have a question for you. So how would you reduce the contact resistance between your heater and then your pipe?
We've considered different methods to try to heat it to reduce the contact resistance. For example, we thought we could try to use copper coils or another item to help conduct the heat from the heating pad to the pipe in order to make it more effective at heating the pipe.
Thank you.
Is the vision for your product to have one device that moves to different locations, or to have it at several locations?
Because of the price being less than $30, we plan on having multiple icebreakers on different parts of pipes that are in like dangerous areas that could freeze. Because some pipes, while on the outside wall, do not need to have an icebreaker on to stop from freezing.
We tested using an infrared thermometer to find dangerous areas in homes where pipes are most likely to freeze.
Okay, very good. That was my next question. Okay, so you have recommended locations where to install them. Okay, looks like we're just about out of time, so thank you very much.
Thank you.
No problem.
Okay, next team up is 3192-1, short circuits. Okay, you may begin when you're ready.
Hello, I'm Caden Stone.
I'm Blake Sanson.
And I'm Evan Spees. And we're the short circuits. We built our robot to protect our environment.
We are losing trees due to deforestation, housing developments, tree disease, and non-natural fires.
Why are our trees important? Here you can see they provide habitats for animals, they help in the production of oxygen, they absorb pollutants, and they filter water. Some fun facts to go along with this is that in 1 year, an acre of mature trees absorbs the amount of carbon dioxide produced when you drive your car 26,000 miles. And also, one tree absorbs about 22 kilograms of carbon dioxide and produces 27,000 kilograms of oxygen just in 1 year.
Our robot will plant trees where there were forest fires, deforestation, tree diseases, and housing developments. Will operate in small urban settings and large open areas.
Here's our robot's programming. So this is the robot's first pass. So as you can see, we have a motor and our infrared sensor, and this is looped. So the motors will continually run until the infrared sensor senses a tree. Once it does so, it will stop the motors and it will close the claw around the tree. It will swing it back around to the back of the robot, and then it will open the claw, planting the tree. Once it does that, it will then move forward slightly and swing the claw back to the start. This is all looped for 2 times for 2 trees on 1 path, but it can be expanded. Our robot will close its claw around the tree at a speed of 50. It will swing the tree around at a speed of 20. It will open the claw, planting the tree at a speed of 50. Our robot will turn, go forward, and turn again, and find its next path.
Code for the final path is it will scan for the distance between the robot and the tree. Once that distance is found, it will close the claw, swing the tree back, and then open the claw, planting the tree. Then it will move forward, swing back to the start, and then it will do this 1 more time, and the program will end. What can you do to help protect the environment?
You can join restoration projects. And you can plant more trees. We would like to show you a demonstration. Our robot will grab the tree, swing it around at the speed of 20, and open it at a speed of 50. It does this for all 4 trees. Here you can see the robot moving along its path. Once it plants this last tree on its path, it will turn right and continue to plant the rest of the trees.
Here's the infrared sensor finding the tree. And once it finds the tree, it will pick it up and plant it. Do you have any questions?
All right, thank you very much. Let's bring it back to, okay, who has questions?
Hey guys, how would like trees need holes to be dug to be planted? How would the holes get dug for this?
So we have a plow on the front of our robot, which will plow the dirt in front of it, and then as it moves behind, it will plant the trees in the trench that it has dug.
I noticed on your demonstration, it got out of alignment. Do you have ideas of how you can improve that for the future?
Well, we were thinking maybe adding extra drips to the tracks. We were thinking maybe that would add extra traction in the dirt. But you guys have anything to add?
Making the dirt moist would also help give it more traction.
Okay,
so guys,
oh, yeah, go ahead, sorry.
Yeah, sorry. So where are you guys at? I mean, are you in the north part or in the south part?
North.
North? Yeah. I had some experience on the tree planting. It seems like a more complex job, than this, but I would say it's a good start and good idea.
Thank you.
Do you have any ideas for how the robot could detect the holes as far as finding them to plant the trees?
We could use an ultrasonic sensor to test and see if there are holes available for the tree.
Looks like Mr. Carberry has a question.
Oh, yeah, go ahead.
How is the land cleared before the trees are planted? And does your mom know you got a box of dirt in the house?
Well, our robot is set to operate in large open areas, such as where in California there are forest fires. So we're expecting that most of the land will already be cleared, where the robot can then plant the trees.
Okay, I think that's about it for questions. Once again, there was a error with the timer, so I apologize for that. But thank you very much.
Yeah, thank you.
Okay, next team up is 3702-1, Robot Access. Okay, yeah, you can start when you're ready.
Let's check the audio for a moment
okay.
with the two devices. It sounds like there's a little bit of a feedback already. Let's make sure the video, the second device has the audio speakers muted, not just the microphone.
Can you hear us?
Yeah, we can hear you.
This way.
I'll go first. I am the leader. It's my turn. Hey, you for me to go first. I will go first. It's my turn. I will go first. I am the leader. I'm go first. Robot access. That's how we wear competition. Now I like that. We are robot access team. I am Rakan Shemri. I am the leader of this team. We work together to get this project. We task was to make sure that everything is completely correct and on time and to contact experts. I collect the data and discuss the ideas in my group. I am grade 8. I am Naif Al-Asmi. I designed and built this project. I prepared and activated the wireless tools and apps. I am Abdulaziz Al-Fandi. I tested the codes and arranged the project process. I performed the codes and connect the electronic parts together. This is our robot. We designed it for people with nation that suffer from severe disability. smart solutions to the problem of buying their needs. We used our skills in math, science, computer, and engineering to build this project. Our aim was to make it easy, cheap, and effective. It's device to help people feel happy and satisfied. The process of creating this project, we searched for information and collect the data about rates of discrimination around the world. We found those facts.
We visited the center, which called Juan Center of Determination, and searched for solutions that can help people of determination in buying their needs and their family needs without others' help. We didn't find any device that achieves this in normally. We studied and analyzed the effect of this device on the users and felt our responsibility towards them. We conducted many.
We promised them to convince the principals and businessmen to apply the idea and create this device in big amounts.
We conducted many experts in science, math, engineering, computer, psychology, architect, who gave many guidelines to help in creating and designing this device.
This device can be got anywhere in different places like gardens, malls, schools, supermarkets, restaurants, streets, and hotels. The project consists of an Arduino board, Bluetooth chip, LED, breadboard, watt, ultrasonic sensor, servo motor, and two mobile apps. The first app is EVA Picture Mouse, which is that the user face for infrared. The detector moves according to the movement of the user's face. The second app is Arduino Central to control the motor for the Bluetooth chip. We are ready for any question.
Coding
The main idea is this device can detect errors from the environment through a sensor installed on the device. The retail sensor is provided in the device. When the battery comes in the device turns on automatically. There are red lights to show that the device is on. In case on the user, you can find other products available on the device. You don't need to choose the product by moving the head and focusing on it for 2 seconds. Once you have the product, the servo motor connected to the product moves. The servo motor is examined in 90 minutes. Servo motor moves and drops the product into the user's back. This device works automatically and also it costs about $500 and it's price effective.
I am so glad that we could use our skills in Arduino to create this device. So please answer people's information.
Thank you. Thank you. Thank you.
Thank you.
All right, thank you.
Good one.
Do we have questions?
In your video, you showed that the device kind of pushes the bottle into the back and it falls down the chute. If someone was to, say, be purchasing like a pre-made meal or a carton of eggs, how would this device work for fragile items?
May you repeat the question again, please?
So in your video, you show the device is kind of pushing a bottle to the back and it falls down the chute. How would this device work for fragile items, such as a pre-made meal or a carton of eggs that would break if they fell down the chute?
اهو شغال معاك خلاص بس اقلب الكاميرا ورا
Here is time with the project go down the motor. Here the battery.
Okay, do you have a method to replenish an item after it's consumed? After it uses the last one?
Do we have a method for what?
Yeah, once if you buy a can of Pepsi, how does the machine get the next can to sell?
اشرح له ازاي ازاي المكنه بتنزل علبه البيبسي جوه الباص بسرعه
بسرعه شويه 15 ثانيه.
رجع علبه البيبسي وشغل تاني.
يلا وقتك انتهى خلاص. نفذ عملي يا ركان. اقعد يا ركان. قول له انا نفذ عملي. ما تعرفوش انت قفلت الكاميرا ليه؟ انت افتح عليه. ابدا نفذ عملي. تعالى وراه تعال من وراه بينه. تعال انت من ورا الطالب عشان نمشي ثاني راسه.
لايك ده نقول له لايك ده. هو اللي عمل
بينه اللي مطلوب. حط عيب بس فوق.
Okay, I think we're out of time, unfortunately. All right, but thank you very much. Okay, thank you very much. It's time to go to the next team. Team 3707-2, Technologic. Okay, do we have both teams? Oh, goodness.
They're coming in. There's four cameras.
Yeah. This is one of the more complex setups.
I think we got everyone. Or, well, there's only 2 people, but
Yep.
4 devices.
Okay, if you're ready, you can go ahead.
Hello, I'm Salang from the Technologic team. The total global death toll of the coronavirus is 941,000 people. To prevent the spread of the coronavirus, I've devised a gate that operates depending upon 2 factors: the presence of a mask and a shield, and the threshold the number of people based on the square footage. This project can be used in all public areas, such as malls and restaurants. Now let's look at the Scratch program. Here I have the threshold detector and the mask and shield detector. Once I click the threshold detector, it should ask me for this amount of square feet. So if I hit 200, the people threshold is 8. So okay.
Yeah.
So
I think you should turn off your camera and zoom.
it's frozen. Okay, I think the Scratch got frozen.
So I'll just start with mine.
Okay.
Okay. Figure out that. Okay. So COVID-19 social distancing. COVID-19 is all over the place and people are trying to prevent it. To prevent it, they have to socially distance and wear masks. And they have to take many more precautions. But no physical human being can detect if they are exactly 6 feet apart or not. So I have built a robot that detects if something is less than or equal to 40 units, which is basically 6 inches away from the robot. I made it 6 inches away because the robot, the Lego EV3 Mindstorms, cannot detect if something is cannot detect if something is 6 feet away because the range is too long. So here, let me share my screen for the code. Here is the code for the EV3 robot. The code is basically saying if something is less than or equal to 40 units, which is basically 6 inches away, it will say, "Hey, back off," which is what I recorded myself saying. Then it will move back a few inches. And this block here is saying that it will be in an infinite loop, and it will repeatedly happen because I don't want the robot to stop. So here is a demo of my can you spotlight the okay, so here is my robot for the EV3 Mindstorms. So once it turns on, it will detect if something is less than equal to it will detect if something is less than or equal to 40 units, which is basically 6 inches. And then it will say, "Hey, back off," and then it will move back a couple of inches. And to make sure that it will detect, I will put my hand here and then it will move back once the program starts. When it starts, and then when it's in my hand, and it will repeatedly do that.
Okay, I'm sorry. I think we're out of time.
Okay.
Thank you very much.
It already ended, so.
All right. Do we have questions? Yeah, go ahead, David.
Can your robot distinguish between a person which is potentially toxic and a wall or a puppy or something else?
Not yet, but that's part of my next steps for the robot, to detect if it's like an object or if it's like an actual human being.
Did you have an idea what kind of sensors you could use to achieve that?
I was using an infrared sensor, but I could see if I could use like it's still like an infrared sensor, but maybe like, because I used a proximity for the infrared sensor, but I think I could use like, I actually don't know the name, but I'll see.
Okay. Okay, back to the machine learning side of the project. Can you explain what you were trying to demonstrate before you had your technical difficulty?
Okay.
I'm just gonna do it.
Yeah, no, you can just talk about it. You don't have to show us.
Oh, okay.
Just talk about it. Just talk. So my project was basically to open a gate based on the factor that the threshold is not breached and that my mask and my shield is on. So the gate over here will open only if those two factors are considered. So should I give a demo?
No, we don't have time for that, but we was at this part of the Q&A, wanted to give you a chance to explain what was happening.
Okay.
Yeah. Okay. Yeah, judges, do you have any other questions? Okay, and I saw that in the your video, you were also counting people that were entering and trying to set limits based on that. Is that correct?
Yes.
Okay. Did you have a method to determine when the level went back down to an okay level?
As in the threshold for normal people?
Yes.
There's actually a counter for every time the gate opens. So if I put 36 as the square footage, the people threshold is 2. So if I try to show my face with the mask and my shield, it would only open once, and the second time it would reject me.
Okay. All right. Looks like we're out of time for questions, but thank you very much.
Thank you.
Yeah, these were some very good presentations. Yeah, thank you all.
Okay, well, thank you, everybody. We have some of the best talent here in the world and some amazing minds and amazing creativity and innovations. At this time, we'd like to bring Dr. Chung out to say a few words.
Hello, I'm CJ Chung, Professor of Computer Science at Lawrence Tech and the founder of Robofest. Thank you so much for your participation today. First of all, I would like to thank all the coaches, mentors, parents, volunteers, and also actually attendees, spectators. Without you, especially at this time, this competition is not possible. Thank you so much. Also, I commend all the students for their excellent and creative ideas and solutions. We had a fantastic panel of judges today. Professor Akanga from North Carolina A&T State University, Mr. Kaveri from Fanuc Robotics, Mr. Mekan from GM, Ms. Meister from Vecna Robotics, Professor Jin from Lawrence Tech, Mr. Santos, Robofest Assistant Director, Professor Siegel, Michigan State University. Thank you so much for all your excellent questions. Lastly, we cannot give enough thanks to Robofest staff, Ms. Pelonis and Ms. Sparks. Thank you. Coronavirus has been trying to disconnect us, but we are all connected here today. Coronavirus is hurting the whole world, but us. So Robofest mascot is so happy because we won COVID-19 all together. So Robofest mascot is dancing. Thank you so much again. See you on October 17th at the closing and award ceremony. Goodbye. Keep learning.
Thank you, Dr. Chung. Thank you, everybody. We hope to see you tomorrow. Tomorrow is the senior exhibition, and you'll see some more amazing projects. So thank you for coming, and let's all keep in touch.
Yeah, I just have one more note that there have been some questions. I know that there's some technical difficulties during the presentation. Unfortunately, we can't really allow more chances live beyond the 4-minute period. However, if you have something to submit, you can just send it to us in the next 24 hours and we will consider it. So I can apologize for the problems. This is the nature of live demonstrations, right? I think even Bill Gates can attest to that.
Right. And everyone has submitted a video. So hopefully your video, you were able to do exactly what you wanted with retakes and editing.
All right, thank you.
I'd like to thank everyone for joining.
You can all log off now. Okay.
Yeah, the attendees can log off. The webinar is concluded. If the judges want to stick around for a minute, we can wrap up. But the attendees can go about the rest of their day. Thank you so much. We'll see you again very soon.
All right. Thank you, Shannon. Great job. Everybody, great job.
Yeah, thank you. Yeah, judges, any questions before we sign off? We're good. I know a lot of you are experienced already, so.
Okay.
The Lawrence Tech side of everything seemed to be pretty bulletproof today, so congratulations. You nailed it.
Well, thanks, David. Yeah, so send me any questions. I'll try to get them out by this time tomorrow, and then, yeah, hopefully have a quick response from that.
Hey, Josh.
Right, thank you so much.
Josh, congratulations. I saw your son.
Yeah.
I was watching him during some of the judging.
Multitasking, very good.
Yeah, he wanted to participate too, but I had to keep things muted. Otherwise, there'd be
He's adorable. Absolutely.
Yeah. How old is he?
He's 5 months today.
Oh, wow. Okay. Congratulations. Great.
Yeah.
So lovely to see everyone. The event seemed to be a great success, and I'm sorry I can't be there tomorrow, but really looking forward to seeing the rest of the presentations online, hopefully.
Yeah.
Okay. Very good.
All right. Thank you so much.